Good day, children. For today's lesson, we are going to discuss prime factorization. Let us now first discuss prime factorization. When we say prime factorization, it is a process of writing a composite number as a product of its prime factors. We can use two methods in finding the prime factorization of any composite numbers. The first one is prime factorization by the factor tree method, and the second one is prime factorization by the continuous division method. Let us now first discuss prime factorization by the factor tree method. We have here step 1. Start with any factors of the given number. For our step number 2, if the factors are not yet prime, continue finding pairs of factor until all the factors are prime. We have here example. For our example number 1, we have here, as you notice, the composite number or the given number is 90. And on the other side, we have also here 90 and another 90. Let us focus on the first image. Our given example is 90. As we said a while ago, start with any factor of the given number. So we get the factor of 90, and the factor of 90 is 2 and 45. If you multiply 2 by 45, the product is 90. So 2 and 45 is the factors of 90. Now, if the factors are not yet prime, continue finding pairs of factor until all the factors are prime. So now, digit number 2, is it a prime or a composite number? Yes, it is a prime number. While 45, is it a prime or composite? No, it is not a prime number, not prime number. So, continue finding pairs of factors. So, we get now the factor of 45. We need to get the factor of 45. And the factor of 45 is 3 and 15. If you multiply 3 by 15, the product is 45. So, 3 and 15 is the factors of 45. Now, 2 is already a prime number, so we write here 2. No need to get the factors of 2 because it is already a prime number. So now, 2 is a prime number. How about 3? Is it a prime or a composite? Yes, digit 3 is now a prime number, while 15 is not a prime number. So what we are going to do is we get the two factors of 15, and digit 3 and digit 5 is the factors of 15. If you multiply 3 by 5, the product is 15. So now, digit 2 is already a prime factor, and digit 3 is now a prime, and digit 3 again is now a prime, so as digit 5. So now, these 4 digits, digit 2, 3, 3, and 5 are now the prime factorization of 90. 2 times 3 times 3 times 5 is now a factor of 90, or the prime factorization of the given number 90. Let us now move to our second example. We have here also the given number is 90, same as our first given number. As you notice, we have here the factor is 3 and 30. When you multiply 3 by 30, the product is 90. So, the factors of 90 are 3 and 30. Now, digit 3, is it a prime or composite? Yes, it is now a prime number, while 30 is not yet a prime. So, again, we continue finding pairs of factor. So now, what are the factors of 30? We have here 3 and 10. If you multiply 3 by 10, the product is 30. So now, 3 and 10 is the factors of 30. So now, digit 3 is already prime number, while digit 10, is it prime or composite number? Yes, 10 is not yet a prime. This is a composite number. So, again, continue finding pairs of factors until the factors are prime. So now, we get the factors of 10, which is 2 and 5. If you multiply 2 by 5, the product is 10. So now, digit 3, digit 3, digit 2, and digit 5 are all prime. So, 3 times 3 times 2 times 5 is the prime factorization of 90. Let us now move to our third example or to our third image. As you notice, the given number is also 90. So, we get the factors of 90, which is 9 times 10. 9 times 10, if you multiply, the product is 90. So, 9 and 10 are factors of 90. Now, digit 9, is it prime or composite number? Yes, 9 is a composite. So, we get again the factors of 9. And the factors of 9 are 3 and 3. If you multiply 3 times 3, the product is 9. Let us move to digit 10. Is digit 10 a prime or composite? Yes, digit 10 is a composite number. Composite number, as we said in our first discussion, composite, those are the whole number with more than 2 factors. So, digit 10 is a composite number and it is not yet a prime. So, we get now the factors of 10, which is 2 and 5. Now, if you multiply 2 times 5, the product is 10. So, this is now the factors of 10 is 2 and 5. Now, digit 3 is a prime number now. Why? Why is it a prime number? Because, as we said a while ago, prime numbers are numbers with only 2 factors. Again, digit 3 is also a prime number. So as digit 2 and digit 5. All the digits now are prime. So, 3 times 3 times 2 times 5 is the prime factorization of our given number 90. Notice that no matter which 2 factors you use first, the prime factors are the same, except for order. As you notice, in this given example, in our first example, the first factors that we use is digit 2 and 45. And in our next example, we have here digit 3 and 30. As you notice, the first factor that we use are not the same. So as our third example, the first factors that we use is 9 and 10. But the prime factor are the same except the order. As you notice, we have here 2 times 3 times 3 times 5. And in the second example, we have here 3 times 3. In the given example, we have here 2, 3. And so as here. And we have also digit 2 here, and we have also digit 2 in our second example. And we have also here digit 5. So as digit 5. As you notice, the prime factor, so as here, digit 3 is 2, digit 2 is 1, and digit 5 is 1. They are the same factors, but the factors that we use, the first factor that we use, are not the same. Do you understand, class? Very good. Now, let us now first discuss prime factorization by the continuous division method. We are now using the second method, which is the continuous division method. In the continuous division method, the composition method, divide the number by any of its prime factor. Repeat this step until you get a quotient that is prime number. So now we are looking again a prime number. We have here example. Again, our given example is the given digit is, or the given number is 90. Now, prime factor, this is a prime factor 2. We divide 90. 90 divide 2. The quotient is 45. Now, 45 is not yet a prime, so we also divide it by a prime number which is 3. 45 divided by 3. The quotient is 15. 15 is not yet a prime number, so we also divide it by a prime number 3. 15 divided by 3, the quotient is 5. Now, 5 is a prime number. It is now a prime number, so this quotient is a prime number. So this one, the 5 is a prime number. The prime factor of 90 is now 2 times 3 times 3 times 5. This one, 2 times 3 times 3 times 5. These are now the prime factor of 90. This can also be written with exponent as 2 times 3 to the second power times 5. This one, the 2. This one is the exponent. Take note that every composite number has only one prime factorization. One composite number has only one prime factorization. Take note of that, class. Recall that 3 to the second power means that 3 times 3. In 3 to the second power, 3, this one, 3, is called the base. And the 2, this one, the 2, is the exponent. The base tells the number to be multiplied by itself, and the exponent tells how many times the base is to be multiplied by itself. For example, we have here 3 to the second power. It means we multiply the base 3 for second time. 3 times 3. If the number is big, it is not convenient to use the factor 3. The factor 3 is the first one that we used a while ago. The continuous division method, this continuous division method is more convenient to use. Okay, if the number is big, don't use factor 3. It is more convenient to use the continuous division method. We have your example. Okay, let us now divide. The given number is 120. We divide 120 by the prime number 5. 120 divide 5. The quotient is 24. So now 24 is not yet a prime. So we divide it by a prime number which is 3. So 24 divided by 3, the quotient is 8. 8 is not yet a prime number. It is a composite number. So we divide it again by a prime number 2. 8 divided 2 is 4. The quotient is 4. Now, 4 is not yet a prime number again. It is a composite number. So, we divide it again by a prime number 2. 4 divided by 2, the quotient is 2. Now, 2 or the quotient is a prime number. This one is a prime number. So, thus, 120. The prime factor is 2 times 2 times 2 times 3 times 5. This one, 2, 2 times 2 times 2 times 3 times 5. These are the prime factor of, or the prime factorization of 120. Or you can also write in this way. 120 is equal to 2 to the third power. To the third power, how do we get this? You only you count 2, 1, 2, 3. We have here 3 digit 2. So we write in this way, 2 to the third power times 3, this one times 3 times 5. Do you understand, class? Very good. We have here another example. For our example number 2, the given number is 180. 180, we divide it. 180 is a composite number, so we divide it with a prime number 5. 180 divide 5, the quotient is 36. 36 is not yet a prime number. It is a composite number, so we divide it again by a prime number 3. 36 divided by 3, the quotient is 12. 12 is not yet a prime number, it is a composite number, so we divide it again by a prime number 3. 12 divided 3, the quotient is 4. 4 is not yet a prime number, it is again a composite number, so we divide 4 by a prime number 2. 4 divided by 2, the quotient is 2. So now, 2 is the 2 is a prime number. So, 180. The prime factor of 180 is 2 times 2 times 3 times 3 times 5. This one. 2 times 2 times 3 times 3 times 5. Or you can also write in this way. 2 to the second power times 3 to the second power times 5. This one, we have here digit 2, we have here digit 2 is 2, 1, 2. That's why 2 to the second power. And we have here 2 digit 3, 1, 2. So, you can write in this way. 3 to the second power times this one, the 5. 2 to the second power times 3 to the second power times 5. These are now the prime factor of 180. That's all for today, class. Learning mathematics is fun. God bless all children. Ang math ay madali sa tulong ni Teacher Jinky.